Okay, so the next thing, okay, my plan was to finish the next 4 page, okay, in today. So then next week we can start a new chapter. Okay, so I'll try my best to finish them all. So I'll be going a little bit faster, but you still stop me if any place that you feel is confusing. Okay, then I can further explain it, because your homework will have similar question here too. Okay. So differentiability and continuity. Continuity, we already learned it from before, right? Continuous at a point. So can anybody tell me what's the rule for checking continuous at a point? Does anybody remember here?
Like, is it defined for all points?
Just 1 point. If I want to check if it's
Oh,
continuous at 1 point, what do we need to do? How can we check if it's continuous at a point? Anyone?
like you can see if there's a, like if it flows, like if it's connected at the point. You know what
Yeah,
I mean?
only if you see the graph, right? How can we do it without the graph? Any calculation that we can do using limits?
Oh, does left limit equal right limit?
Yep, very good. Left
And
limit
then
equals right limit. Is that all?
and then if the limit of the entire thing, if they have to equal each other, and
Yeah,
then that point has to like exist.
and also equal to the point as well.
Yeah.
Okay,
And
so
then
left limit equal right limit equal to the point. Okay, I hope you haven't forgotten that. Okay, so we have two things here. So this is checking if it's continuous at a single point. Now, because we have learned derivative, so differentiability means if it's derivative possible, is the derivative possible at that place? We call that differentiability, okay? If it's differentiable, that means you are able to find the slope at that place, okay? So differentiability is able to find derivative or not, okay? The ability to find derivative, okay? Continuity is if the graph joins together at that point, if there's any gap. Differentiability is talking about whether you can place a tangent, right? Placing a tangent at a point or not, different things, okay? So here we have a theorem, and then we're gonna use the example to show you why the theorem is correct, okay? So here we have a function if it's derivative possible, right? If it's differentiable, then it must be, right, guaranteed continuous, okay? Which means if you are able to place a tangent there, then for sure it must be continuous there. There's no gap. Okay, I think this is easier to understand, right? For example, if I draw a graph, right, and then if I'm able to place a tangent, let's say here, I put a tangent there, that means at that point you shouldn't have a gap, right? Because if you have a gap, how can we place a tangent, right? So if you already have a tangent there, that means that place has a point, right? It doesn't break, okay? However, the converse, okay, let's write it here. This is called converse, right? If I want to go backwards, right, continuous does not guarantee differentiable, okay? So that's what I'm saying here. If f of x is continuous, not always differentiable, okay? Sometimes differentiable, sometimes not, okay? So there are rare cases that doesn't guarantee differentiable, okay? Even though the graph is continuous, you still cannot put the tangent there at the point, okay? We're talking about a single point. So the following two examples are the example that's showing the case 2, okay? Continuous, but not differentiable. So two things we need to show. First, we're gonna review how to check continuous, and then the new thing is to show how do we show it's not differentiable, okay? By calculation, not by the graph. So we will start with something easier, okay, with the absolute value. Whenever you see absolute value function, what's the very first thing you need to do?
Split it into the less than 0 and greater than and equal to.
Right, the piecewise function, right? So what is the first piece, Jeffy?
It's just the x and then comma, and then x is greater or equal to 0.
Yeah, very good. Second piece.
Negative x, comma, x is less than 0.
Yeah, very good. Okay, so first thing we're gonna show that it's continuous. And then we're gonna show that even though it's continuous, it's not differentiable there, okay? So let's write that down. Show continuous at x equals 0, okay? That's our first job. And to show continuous, as we mentioned above, we need to do left limit, right limit, and the point. See if they equals. So let's start with the left side. We're checking 0, right? Approaching 0 from the left, approaching 0 from the right, and f of 0. And then from here, you need to pick the pieces. Approaching 0 from the left, which piece should we pick? Leon.
Negative x.
Okay, and then the answer should be what? Leon, still you?
Sorry, 0.
Yes, okay. Now the right piece will be picking which one, Emily?
The other one.
Okay, and the answer?
0.
Yeah, okay. And f of 0, you can plug into the first one, will be 0. So from here, left, right, point, they all equal. So therefore, continuous at x equal to 0. Okay, so that's the easy part. Now to show differentiable or not at the point, then we need to find the slope as it gets close to that point, because we don't know if it's differentiable at that point or not right now, okay? So we will find the slope, right, using our definition, okay? You can use any of the first two, okay? Do you understand what I'm talking about? We have three definitions, right? Because we're checking derivative at a point, so it's either number 1 or number 2, okay? It doesn't matter which one. So let's pick number 1 then, okay? For next question, we'll do number 2. Okay, so let's say here, our goal is to show not differentiable. Okay, the question tells you it's not differentiable at x equal to 0. Okay, this is our goal right now. I want to show that. So I will find the slope at 0, and we are using the first one, right? So I will take the limit x approaching 0. I will start from the left side. So x approaching 0 from the left, which means it's finding the slope coming from the left side. Okay, and to show that the prime is from the left, we will also add a little negative. Okay, do you see it? We have negative at the bottom corner of f, which means it's the derivative from the left side of 0. Okay, and then the definition is still the same. Okay, it will be f of x minus f of 0, okay, over x minus 0. This is using definition 1. Okay, definition number 1. Any questions so far? If you are confused how I get that, please let me know. Okay, So now we will subbing the function, okay? Approaching 0 from the left. So our function, we should pick the second one, right? Because it's less than 0. So it will be negative x minus f of 0, which is 0, over x, right? We'll simplify that. That will be negative x over x. That will give you negative 1, right? There's no x to sub in, right? There's no variable anymore, so it will just remain negative 1. So this is telling us that the slope coming from the left side is negative 1, okay? Now, the next one is going from the right side. So limit x approaching 0 from the right, same definition. Okay, so I'll let you carry on the next couple steps by yourself. Okay, please raise your hand if you get an answer. Okay. Anyone has question about how to do this part? So coming from the right side, you need to pick the side, the x as the right piece, right? So that will give you limit of 1, which is 1. Okay, so the slope coming from the left and the slope coming from the right, the limit does not equal each other. So that means we don't have a consensus, right? We don't agree. The two sides, they don't agree, kind of like the limit, right? Checking left limit, right limit. If the limit doesn't exist, that means the derivative doesn't exist, okay? We can write because the prime from the left side does not equal to the prime from the right side, therefore not differentiable at x equals 0. Okay, because the limit doesn't exist, right? Left limit, right limit, they don't equal each other. So that means the limit doesn't exist. Limit doesn't exist means it's not differentiable there. Okay, so let's see why it looks like this on the graph. What's the shape of the absolute value graph look like? Joan?
It's like a triangle, like pointy kind of thing.
Yeah, and where is the pointy part?
0.
Yes, okay, so it looks like 0 at the middle, right? And then pointy to the left side and the right side. So now let's think about the graph, the continuity, right? So obviously this graph, there's no gap. So it's continuous at 0. Now the first part of the derivative, the slope from the left side, we got negative 1, right? Negative 1 means we're talking about the slope of the left line is negative 1. That's what it means on the graph. Okay, and then slope coming from the right side of 0 is talking about the line on the right side of 0, right? As we go close to 0, the slope will be closer and closer. It will remain because it's straight line, right? So it stays as 1. From the left side, the slope remain as negative 1. So when it's very close to 0, you don't know which one to take as the derivative, right? So the slope at the center, there's no single value for 0, 0. Right? I don't know whether I should call that place equal to 1 or negative 1 as slope, right? We cannot we cannot use both at the same time, right? So that's why it's not differentiable. Okay, so that's the idea. If you get more than one slope at a point, then it's not differentiable. Okay, right, so that's, I'll let you try this one. Okay, so same thing, we're gonna show continuous, and then we're gonna show even though it's continuous, but it's still not differentiable. Okay, show continuous at this time is at 0 again, right? And then we're gonna show not differentiable at x equals 0. And this time we're gonna use definition 2 to practice. Okay, so in the homework you can use either one. You can use 1 or 2, doesn't matter. This one, because it's not absolute value, so you don't need to write piecewise. So there's only one piece. Okay, once you finish the continuous part, please raise your hand. Okay, let's check the function that you use. There's only one function, right? So there's no choice. Has to be x 2/3 for all of them, right? So we just sub in 0. So it'll be 0, right? 0. F of 0 still 0. So therefore continuous. Okay, this one easier, right? You don't need to pick the pieces. Now the second part, we want to show not differentiable. I want to use second definition. From the left side at 0. Okay, the second definition is the one that has the h. Okay, if you haven't memorized this, please do that. Okay, please make sure you find time to memorize this. So can anybody tell me what to put inside the numerator? Carrie, can you tell me what to write in the numerator?
Is it a like bracket a plus h to the power of 2/3?
Not bracket, and what's the a here?
0.
Yeah, so 0 plus h to the 2/3, right?
Yeah.
And then
Minus 0.
to the 2/3.
Yep.
Yeah, okay, and then all over
H.
Yeah, very good. Okay, so this is using definition 2. Okay, make sure you know how to use both definition. Okay, right, continue. Right, so please find the answer for each limit, and then we're gonna do the right side as well.
Wait, Jason.
Yeah.
So I went through and I did the right side too, but
Yeah.
I'm like a little confused
Which one
because
I'm confused.
anything squared is positive, right?
Yeah.
So like, won't I get like the same answer, kind of?
Then if it's the same answer, that means it is differentiable, right? But we know that it's not differentiable, so something went wrong in the middle.
Okay, thank you.
So h approaching 0, you have to do h approaching 0 from the left side. okay? And the other one is h approaching 0 from the right side, okay? So here the little difference is you need to add a little minus sign and the plus sign, right? Just like the above example, right? X approaching 0, that's the definition, right? But because we are only doing one side, you need to add a little minus and a little plus, okay? So let's simplify this. 0 plus h is just h, right? So h to the 2/3. 0 to the 2/3 is still 0, right? So over h. Okay, how do we continue now? Leon, how do we simplify this expression?
Would it just be h to the power of 1/3?
Close, 90% correct.
Let me think.
Yeah, what do you think?
I have no idea.
How did you get 1/3?
Because it's like squared, right? So it's like h times h. And then since you're dividing by h, it's just divided by that h, I guess.
Oh, okay, I see. Actually, you have to think about these two they both have exponent. The top has 2/3 as exponent. The bottom has exponent of 1, right?
Oh yeah, that way too, yeah.
And then when you divide two things with the same base, what do you do with exponents?
Subtract.
Yes. So how do you subtract?
Oh, okay, subtract by common denominator, right? So h to -1.
Which numbers do you subtract each other?
Are you subtracting 2/3 by 1?
Yeah. Can you subtract by yourself and tell me again?
-1/3.
Yeah, so answer should be h to the -1/3. Okay. Right, and then let's go to, because there's it doesn't matter which side it comes from. Well, actually it does, right? Let's see what it looks like now. So it become limit h approaching 0 from the left. -1/3 means 1/cube root, right, of h. Now, if I sub in a small negative number, right, that means it's 0 from the left side. A very tiny little negative number. What's the cube root of a small negative number?
Negative.
It's still negative, right? So it'll be 1 over a tiny little negative. And what's 1 divided by a tiny negative?
Still negative.
Yes, and it's a negative what?
Big number.
Yeah,
Negative infinity.
negative infinity for this
Yeah,
one.
that's what it's called.
Okay, so this is something that we learned when we went over in infinity questions, right? We need to imagine there's a small number, right? And it matters if it's 0, because left side of 0, right side of 0 is a completely different result, right? Now for the second part, it will work the opposite, right? Everything will be similar, right? So I'm gonna skip to here, right? H to the -1/3, because it will end up the same place. And then same thing, instead of negative small number, it will have a positive small number. So we'll end up with a positive infinity. So once again, the left derivative and the right derivative, they don't match, right? Even if they both match, even if they are both positive infinity, it's still not differentiable, right? Because it's not a number, right? In order for the limit to exist, it has to be a number, right? So you know right away it's not differentiable, okay? So we can write because left slope does not equal to right slope, therefore not differentiable at x equals 0. Okay, so let's see what graph we have here, okay? I'm gonna share a different screen, okay, to show you the graph. Okay, and then here, I'll type in use the decimals. Okay, so the function that we have is x to the 2/3. So there you go. Can you all see the graph now? Jesse, can you see it?
Yep.
Yeah.
Yeah.
Okay. Right. So if you look at the graph, if we zoom in, right? If we come from the left side, it becomes closer and closer to a vertical tangent, right? But it's a negative. On the left side, the tangent lines are negative. On the right side, the tangent lines are positive. But once they get close to the center, the left side is negative infinity, right? Because it's almost vertical, right? Right side will be vertical, but it's positive. Okay, that's why we get the result. Okay, so I always say is that the calculus is like a microscope, right? You can look into it, right? If we zoom in, right, the tangent line becomes vertical. Okay, so let's go back and copy that graph to here. Okay, so let's change the sharing. Okay, so here's the curve. So it goes like this. That's the right side. And then the left side. Okay, it should be symmetry. Okay, and then the tangent line. Right, these are tangent lines. Everything on the right side are positive, right? And then everything on the left side, they are all negative. As they get closer to the center, it becomes infinity. Okay, so that's why you get the two results. So in the homework, well, you will have something like this. Okay, you need to find slope from each side. Okay, sometimes you get different, sometimes the same. If it's the same, then it's differentiable. If it's different, it's not differentiable. Okay, as easy as that. Any questions so far? Okay, then we'll look at next one. Question 12. Okay, here we have a piecewise. So please sketch and determine where it's discontinuous, right? So that's the first thing, right? You want to check continuous or not, and therefore not differentiable. Okay, you also want to show that not, well, if it's not continuous, for sure it's not differentiable. Okay, so you just check continuous or not. So don't draw the graph yet, okay? I want you to try to check continuity without graphing, okay? And then we'll double check with the graph, okay? So there's only one thing to do, just check discontinuous. So how many places do we need to check?
One.
Only one place? How do you know?
Oh, sorry, two.
How do you know there are two places?
Because the -1 and the 0.
Yeah.
There's only 2 points that they give you.
Yes, okay. You only have the points are where they get separated, right? 1 point is at 0, right? Greater than 0, less than 0. So that's the point of splitting, right? So you look at the domain. It tells you that we need to check x equal to 0, x equal to -1. See if they are continuous or not, right? So x equal to 0, and then we'll check x equal to -1. Okay, once you finish the checking for those two, please raise your hand. Okay, let's check the pieces now. Okay, so Emily, can you tell me for x equal to 0, from the left side, which piece did you pick?
I just picked 0.
Okay, so it'll be 0. How about right side?
X cubed.
Yeah, so that will also be 0. How about f of 0?
0.
Okay, so that means it's continuous at x equal to 0. Okay, next one. Approaching -1 from the left. Nicole, which piece?
I picked the 4x,
So the answer is,
-4.
okay, right side.
Oh, is it still me?
Yeah, still you.
Okay, right side, I picked 0,
Yeah, answer will be 0. How about f of -1?
0.
Yeah, okay, so because they don't equal, so it's discontinuous at x equal -1. Therefore, right, if it's broken, that means it must be not differentiable. Okay, at x equal to -1. But this one, for x equal to 0, even though it's continuous at x equal to 0, but it doesn't guarantee differentiable, right? If you want to see if it's differentiable, then you need to do the left derivative and the right derivative, okay? To see if the left and right side equal each other, okay? So right now, we only know it's continuous there. We don't know if it's differentiable, okay? Let's see the graph. So x greater than 0 is a cube, right? Cubic. I will draw with the red. Cubic looks like this, right? This is x cubed. And then for the middle section, -1 to 0 is a 0. I'll use the blue one. So -1 to here, right? Empty circle there. And then you have -1 is -4, and that one is empty circle. I'll use the green. So it'll be here, and then positive slope. Okay, so the 3 pieces, that's the graph, right? So at -1, it's not differentiable because it's broken. At 0, right, if you think about the slope, right, without doing the work, the slope coming from the right side, eventually it will become flat, right? You see that the tangent line will become flat. Start from here, become flat, so it'll be 0. And then the slope coming from the right side, left side, because it's already a flat line, so it will be also flat. So from the graph, we can sort of see that it will be differentiable, okay? But it's not really a proper proof. If you want to show the work, you have to do the left slope and the right slope. Okay, any questions? All right. Okay, if nothing, well, let's make a conclusion here. Okay, so based on all the example from up to now, right? Even from the graph here, there are places that is not differentiable. Okay, so those are the places you have to memorize. So when you see the graph, you know right away. Okay, it's not differentiable at those places. So first place is when you see a cusp. Okay, cusp or corner. So basically, it's the places that is a sharp point. Okay, so for example, if the graph looks like that, and then it bends, right, very sharp, right, or it looks like a parabola, and then suddenly it makes a straight line. So those are corners and cusp. Okay, so this place and this place. Okay, so at x equal to a, those are the places not differentiable. Okay, and the graph goes on. Now endpoints, right? So for example, if I have a graph that goes like that, right? So it will be differentiable everywhere except at this end, right? Because at that place you cannot put a tangent line. Also, you can think about there's no left slope. You only have the slope from the right. So it is differentiable from the right side, but there's no slope from the left side, right? Because it stopped. Any questions so far? Okay, so it's only differentiable from one side, but you can just say not differentiable, okay, at point A. Next one, discontinuous will be the example that we did above, right? So we could use that. So for example, you get something like this, empty circle, and then broken, right? So this place is not differentiable. Okay, so this is for discontinuous. Another possible way to have discontinuous is when you get asymptote. Okay, so I'm gonna fix this graph. So for example, you could have going down infinity, right? So that's also not differentiable. And then continue from the other side, right? It's broken. So this place is also another place that's not differentiable. Okay, all the A are the place for not differentiable. Last one, the vertical slope. Okay, we have vertical slope before, right? Like a circle will have vertical slope. Another graph that has vertical slope will look like this. Okay, so the tangent line at the middle, right? Tangent line here, right, is positive, more positive, and then become vertical, right? And then less positive, less positive, less positive. So at this place, that's where it's not differentiable, okay? So 3 places. So I would like you to turn your mic now, okay? Let's repeat the 4 places together, okay? Everyone, please turn your mic. Lex, you there? Yeah, okay, so let's say it together, okay? Not differentiable.
Not
Not differentiable.
Differentiable.
Cusp or corner.
cusp or
Cusp
corner,
or corner.
Endpoint.
endpoint,
Endpoint.
Discontinuous.
discontinuous,
Vertical.
Vertical.
Okay, one more time. Cusp or corner.
Cusp
Cusp
or
or
corner.
Corner.
Point.
endpoint,
Endpoint.
Endpoint.
Very good. Discontinuous.
Discontinuous.
Vertical slope.
vertical slope,
Vertical what? A slope, my bad.
Vertical slope. Okay.
Sorry, I went blind for a second.
Yep. Okay. So we'll finish the last 2 pages next time. Okay. And then I'll send you the homework later tonight. Okay. If you have questions, you can stay afterwards. Otherwise, I'll see you next week.
Thanks, Jason. Bye.
Thank you,
Thank you.
Jason.
Bye.
Thank you, Jason.
Bye. You're welcome.